This is our first Evo-Devo Universe book group, Evo-Devo Institute book group meeting. And we are honored to have Daniel Brady Mills leading the discussion of Simon Conway Morris's latest book, From Extraterrestrials to Animal Minds. Thank you so much, Daniel, for guiding us through this.
Of course, as this is my first group interaction with everyone here, do you think we could do a quick round of introduction? Just so
yeah.
So I'll just start. So I'm Dan Mills. I recently joined this group. I'm a postdoctoral researcher at the University of Munich, and my background is in geobiology. So the coupled evolution of Earth's surface environment and life over geologic time. And now I'm applying my interest in geobiology to the prospect of alien biospheres. But I suggest, David, do you want to introduce yourself?
Well, I'd be happy to. And by the way, I'm in recovery. I won't get into the details. I have a great appetite, and I have a great appetite for our discussion. I'm a professor emeritus from Howard University. I actually retired 13 years ago, and I have continued research on various topics, including the long-term history of the Earth's biosphere, and also on climate and energy issues, and a few other things like the origin of lichens, which I'm very interested in. Anyway, a very quick introduction, and please, whoever wants to go next.
Sure, Carlos?
Hey, I'm just, sorry, I'm in the coffee shop, so I'll try to be quiet a little bit. I'm Carlos Mariscal. I'm a philosopher of science by training, philosopher of biology in particular. I do philosophy of astrobiology and have done quite a bit of work on universal biology, that is what we could expect from life everywhere in the universe, how it seems to be, origins of life, and sadly, definitions of life. I say sadly because you make a claim to fame in a thing, and then all of a sudden, that's, yeah, philosophy of stuff.
Great. Pushkar?
Yes, hi, I'm Pushkar. So I'm based in Mumbai. I'm associated with the Indian Astrobiology Research Foundation. And well, I primarily like to work in panspermia and anything to do with it, so the cosmic origins of life. Presently, as an organization, we are working with something called the Luna Crater, which is in the west of India. Perhaps it has some extraterrestrial origins. And yeah, nowadays a little bit dabbling with any spiritual, convergence with evolution.
Very cool. Steve, do you want to introduce yourself?
Yeah. Can you hear me?
Yes,
okay.
Fine.
Yeah. Steve Walk. Let me see. The camera I had trouble with the camera. Let's see. There I am. Yeah. The Steve Walk. I a long time member and sometime contributor to Evo-Devo. My background is engineering and modern physics. My research was back in the day, 30 years ago, was revolutionary, looking for non-Newtonian models for technological change and social change. And since then, I've retired, and I've just been enjoying all of the discussions on Evo-Devo. That's me.
Great. Addie, would you like to introduce yourself? Oh, you're on mute. There you go.
Is that better?
Yeah, perfect.
Okay. I'm a chemist that's become very interested in biology, and I'm happy to hear what people have to say about a very interesting biologist, Conway Morris, and his ideas on convergent evolution, which I strongly endorse, but wanting to hear what people have to say, and I'll be happy to kind of join in where it may be appropriate.
Perfect. Charles.
Sure. Hi, everyone. I'm Charles Fadel. I'm founder of the Center for Curriculum Redesign. We work in K-12 higher ed and workforce development to adapt curricula to an age of AI. I have a background in electrical engineering and MBA.
Perfect. Julian, would you like to introduce yourself?
Mute.
Yeah, it's like on the bottom left of this taskbar.
Found it. Okay. Sorry, I got 3 screens and I'm on the wrong camera. Okay. Sorry. Are we introducing ourselves?
Yes.
Okay. Julian Goff. I'm a weird writer. I write weird stuff. I write novels and stuff. I wrote the ending to the computer game Minecraft. And now I'm writing a book about cosmological natural selection, but I got so interested in it, I'm kind of extending the theory. And I ended up making some predictions about the early universe before the James Webb came online that turned out to be accurate. So now I'm getting funding for my research. So I suddenly find that I'm a cosmological natural selection researcher. And that's been going pretty well because I think it's actually true. I think the evidence that the universe did evolve is starting to get kind of startlingly solid. So I'm having a strange period in my life. And this is great. I love this discussion. So I'm a little behind on the reading, but I will catch up. Okay, thanks.
Perfect. Thank you. William, are you there to introduce yourself?
Bill Buckley, are you there, Bill?
Oh, Bill, yeah, thank you. Oh, no microphone. That's okay, yeah. And then John, for completion, you want to end us off?
Oh, sure. I'm just very honored to have this wonderful community. I'm a systems theorist, trained under James Greer Miller, who wrote Living Systems back in the 70s, Harvard. Really interested in the systems theory of evolution and development and the intersection between those two. And this idea of universal development and universal biology that when Carlos came in early and helped us think that idea through, we thought it was just a fantastic idea. It's great to see now this term is getting more cachet. So yeah, thank you.
Perfect. And that's everyone now. Did I miss anyone? Okay. So I just wanted to start with some context. So I remember when I was a bachelor student learning evolutionary biology formally for the very first time. This is back in 2006-07. Going into evolutionary theory, I did come in with the kinds of these popular notions of the march of complexity and kind of the near inevitability of human-like intelligence. And when I first came across Stephen Gould's work about the role of contingency and how unlikely this particular evolutionary outcome truly is, if we were to replay the tape, so to speak, we would get a completely different outcome. And I found those ideas to be very radical because they challenge what I had thought at that time. And that's when I was introduced to Simon Conway Morris. In my initial perception of him is that he was a crank, like, to be completely honest. And that's how he was introduced to me by my educators. And that he was people always made clear his religious beliefs and that his beliefs have soiled his intellectual integrity, and that he wanted humans to be a near inevitability. But if you actually look at the paleontological and biological data, that is simply an ideological conclusion. The data don't actually say that. And that's how I viewed him for a long time. And now I think it's kind of funny all these years later. I'm reading his book and I find myself agreeing with most of what he's saying. And so I think it's kind of funny how I've kind of come full circle with respect to how I view him. Well, I thought he was a crank, and now I actually think he's quite brilliant. And this book I found, I wanted to read his latest book because I want to know what he was saying now. And actually, I've never read his most famous book is called Life's Solution, like Inevitable Humans in a Lonely Universe, where the main premise is, as far as I remember, without having read the book, the origin of life was an inherently improbable event. But once you have life, the evolution of something like a human being is almost guaranteed. And he primarily bases that argument on convergent evolution, multiple independent lineages, primarily in the animal kingdom, that kind of come to the same solution to similar adaptational problems. So like similar morphotypes and ecologies re-evolve in different lineages over time. But this so this is the first time I've actually read one of his books, and so far I really like it. These first 3 chapters I find to be very interesting. So I'll briefly introduce the first chapter, and then we can discuss it, and then we can go in order. But the myth of no limits, I find this to be really interesting because I've now started talking to more astrobiologists, and especially a lot of astronomers who are interested in life on other planets. And I give astronomers a lot of credit because I feel like in their community, they're allowed to speculate more wildly without any repercussion. So they tend to think about life as we don't know it, exotic biochemistries, where silicon-based life as opposed to carbon-based life, or liquid methane as the solvent of life over H2O. And I've found myself to be relatively conservative in these circles because I kind of push back, and I think a lot of what we see in Earth life is, in my view, not contingent. It's highly constrained, and not everything you can imagine is realizable by nature and biology. And I found that most astronomers do not like that. They push back on it. They think it's very chauvinistic and in Earth-centric, parochial. And Simon Conway Morris is clearly aware of that perception because he makes that caveat many times. But I actually think he does a really good case in this chapter of showing the kinds of constraints that evolution is subjected to. And that actually, this is idea that there's this essentially like this infinitely large biospace, and life on Earth has only realized a very small percentage of it. And why did life on Earth realize some forms and not others? It's largely contingency and it's random. If we were to replay the tape, we would get a completely different filling in of this biological phase space. But I really like in this chapter making a case for the sorts of physical and chemical constraints that life is subject to, and that actually a lot of what we observe about life on Earth actually might be universal, applicable to life beyond Earth. So I actually really liked how he presented this, and I'm very curious what you all think about his arguments in these ideas in general.
Guys, feel free to put your hand up if you want to do a hand in order for Daniel questions, or jump in, I guess, whatever Daniel thinks.
Yeah, please just speak up. And then if we have too many people speaking at once, we could do hands. But if anyone wants to jump in there and start, yeah, please.
I'll jump in if no one else will. It's actually there's so much hinges on that. How constrained is life in this universe, like once it starts? And I think cosmological natural selection, which is the thing I'm obsessed with and I'm working on, would have some expectations around that. So if cosmological natural selection is right, and if the cosmological natural selection plus intelligence is right, which John Smart's helped to develop, Clement Vidal has helped develop, and intelligence actually helps universes reproduce, then universes will have been evolved over a very long period to fine tune for the development of life, which means that the elements themselves will have evolved to enable life, especially slightly further up the periodic table, you know, and then to probably to evolve technologies and that. And so in a way, I think that that means the constraints are because the parts themselves evolved. So you would say something like phosphorus and ATP are going to be, or possibly something like universal, that essentially, you know, that you won't necessarily have DNA just like the DNA on Earth. No, sure. You won't necessarily have cells exactly like on Earth. No, but there'll be something very like ATP, and it's very hard to see what you replace ATP with in terms of really efficient delivery of chemical energy. You know, you see it in plants, you see it in animals. We didn't evolve a different delivery system. You know, we've got a lot of convergent evolution going on Earth, but they're all using ATP. They're all using phosphorus. None of them are using arsenic. You know, so I think cosmological natural selection has a big role in this argument. And anyway, you talk, Daniel, because I haven't had time to read up to the point, but I think that you should be able to see, you should have incredible diversity within a tight range of relatively fundamental constraints if the universe actually evolved, if you see what I mean. Anyway, I'm just rambling slightly, but you take over.
Yeah. Just to jump on Julian's point, I love this phrase stochasticity, right? So random within constraints.
Random within constraints.
So you should see these stochastic steps. And when he talked about carbon for
C4 photosynthesis,
being reinvented. What was it? 4 times, 3 times?
It was more than I thought. It
was way more than I thought. And what a great example of when you get to these extremes, you know, you're going to have this other thing, and you're going to find every time you get to these extremes of these dry and hot climates, you're just going to go to this other. It just seemed like another one of those portal pathways, right? I love that phrase from complexity theory: search landscapes and portal pathways, right? There's going to be some portal pathway that constrains the optimality. And it's like he's just finding the easy ones right now and talking about them, like carbonic anhydrase and C4 photosynthesis. And probably someone's going to figure out like phosphorus, just like we figured out organic chemistry, right? It had to be carbon. So why does it have to be phosphorus, right? Like there's probably some beautiful constraint there that, and then we just admit that it's so stochastic search within that space, and that's why on random sample it doesn't look developmental. Sorry, I just wanted to jump in on what Julian said. I felt the same way.
Yeah, right. Good.
Phosphorus and ATP.
Is it possible to share anything? I was trying to copy and paste an image, but I don't know that I can.
You can just share your screen. Yeah, you can share your screen. I think that's the only easy way. You can also put a link in the meeting notes.
I can't share my screen. Firefox may not have screen recording permission. Oh, I'll figure it out. I've got so the reason I asked is I wrote this review a couple of years ago about this book by George McKee that was it's going to require me to restart this thing, so I'll just describe it. I wrote a review with then Russell Powell, and it was about this like idea of convergent evolution and the same things popping up again and again, which is, you know, I guess what we're talking about. And one of the things that we point out is that not all instances of repeated traits are the same and should not be treated the same, right? If we're actually trying to test universal claims, what we want is relatively independent testing conditions, given the, understanding that we all share common ancestors, or at least common ancestry. So we won't have true independence, but we can have relative independence. And then we also talked about specificity of the repeated outcome. And then I think the last one was scope, which is like how general do we expect the environment to be to get these same results. And to do justice to the opposite view here, not represented by Conway Morris, if the range of outcomes explored, even if we have like the same 2 or 3 things popping up here again on Earth again and again, it might be just a small percentage of the kinds of things we would expect it given an infinite time or given many infinite iterations or many iterations of Earth type things, right? So the mere fact of repetition, even a very specific, very independent, very general, is not going to speak against Stephen Jay Gould type point in this discussion. So maybe I'll post a link to the page for you guys.
Yeah, I would definitely like to read that, because I was thinking while reading, maybe I'll jump ahead to some of the other chapters at this point, but because I've heard rebuttals against Simon Conway Morris's thinking, for example, by Charlie Lineweaver, who I know David has worked with before, and also one of Simon's colleagues at Cambridge, Nick Butterfield. And I can imagine what they would both say, like with respect to the multiple origins of C4 photosynthesis. Yeah, that's originated multiple times in one clade, plants, which evolved once. Embryophytes have evolved once. There are multicellular phototrophic eukaryotes like kelp, but we don't have kelp forests, maybe because land plants were already there, who knows? But specifically so I've heard Charlie Lineweaver make arguments like that, but then also Nick Butterfield has said, fine, there are these examples of convergence and they're really impressive and they're amazing. And Simon Conway Morris has done a good job compiling them. But in his words, convergence doesn't happen when it matters, meaning in what Nick was referring to, the evolution of oxygenic photosynthesis in general, the origin of the eukaryotic cell in general, the origin of an animal body plan in general. These are all things that apparently have happened once, not convergently. And I'm thinking of that the whole time I'm reading this book. And I don't know if he'll get to it in the later chapters, but so far he hasn't really seemed to address that. And to me, that's my biggest critique of his view. And I have tried in the literature to get around these issues, arguing that these events, like the origin of oxygenic photosynthesis, actually aren't singular. Maybe they happen multiple times, and it's information loss. It's an artifact that we reconstruct a single origin, because these things happened billions of years ago, and we don't have enough information to confidently say it only happened once. Or maybe it did happen once, but because there are certain ecological constraints that prevent subsequent origins from happening. Like once land plants, embryophytes, colonize the continents, maybe they prevented other phototrophic lineages from following suit, making them seem more special than they really are. I don't know if Conway Morris would agree with that logic or not, but I do find it, it's an issue for me that he doesn't explicitly address this, because this is what comes up for me. Even though I agree with him overall, I just wish he would address these critiques.
I totally feel the same way with you on that, and I call that competitive exclusion.
Right.
So a particular kind of ecological constraint that involves a competitive exclusion, where a form emerges that just dominates the resource use.
Exactly.
And I don't know, and I did find 2 or 3 places where he actually mentions examples.
Oh, good.
So I'll try to
Okay,
explain
great.
some
Yeah,
of that.
please.
But I agree with you. I don't think he puts it, he doesn't put that idea front and center, but it does feel like one of the key constraints one would have to talk about if you're looking for universality, right? It's got to be an attractor there, something around maybe energetics or informatics or something like that, right?
Yeah, I completely agree.
So Christian Beduve in his book Singularities talks about these sort of
Right.
one-time occurrences,
Um,
which could be for competitive exclusion principles. You might call it competitive advantage. It might be a frozen accident. There's all sorts of
Right.
reasons why a thing might occur just the once, and
Right.
they don't
yeah, let me
necessarily
ask you,
speak to
Carlos, would
contingency.
you agree that frozen accident could be path dependency, like choosing the right or left hand of driving on the street, whereas the competitive exclusion would be another one of those constraints, right? Those two might be different, right?
Yeah, I think they're very different, and
Yeah.
I think if you just look at the outcomes without paying attention to the setup or the nuances of like how bowel plans work and how environments work, you might not be able to distinguish the two. I don't think it's impossible to distinguish the two, but I think just the pattern might be confusing.
Oh, I had one last meta comment to make, Daniel. Simon Conway Morse responded to my invitation after I told him we were reading his book. So if anyone has any questions for him, we could consider having him come in to the next book group or have a separate one. But I think he'd be very interested. So just
I think that would be amazing. That'd be such a good opportunity, you know, yeah, whether it's a follow-up to this meeting or a separate thing, just to have the opportunity to ask him directly would be fantastic.
well, I'd say simplest plans are best. So why don't we just invite him to the 1-2 months
Yeah,
from now? And then
I think it's
maybe,
perfect.
okay, yeah, I'll move it if we have to, but just to get him in.
That'd be so much fun. Yeah, that'd be, yeah, I want to know, because actually in the acknowledgements, I noticed that he acknowledges Nick Butterfield. So I imagine they must have had this conversation already. He must have heard these critiques from Nick, and I'm really curious what his response was, and he could simply share it with us. But yeah, it's been in the back of my mind. But I think this it doesn't challenge his main thesis. I think, you know, these competitive exclusion mechanisms are right. In Deduve's book, he does go through multiple ways of explaining an apparent singularity. And it could be that some of these mechanisms or explanations are still consistent with everything Simon Conway Morse is arguing here. But it'd be, for me, it would be good to have that more explicitly addressed and integrated.
I've got a. Oh, go on. Were you going to say something, Eddie?
Well, let the chemist in the group maybe say something. Maybe a little bit of background might be helpful. I worked in the area of chemical reactivity for, I guess, maybe 3 decades, and didn't go near biology because I said, I'm a chemist, I'm not a biologist. So I do what chemists do. I worry about chemical problems, and biology is someone else's field. Why should I? I shouldn't be bothered with that. Until it was roughly the year 2000, it suddenly hit me like a bolt out of the blue that the fact that chemistry became biology was the mother of all chemical problems, except that most chemists don't talk about it because that's biology. And once that bolt hit me, I kind of started looking into it. And for the last, well, now it's 25 years, I've been working on nothing else but how did chemistry become biology? So first of all, I've got a chemical point of view on this. When we ask a question, why does A become B in chemistry? The answer is very clear. We know exactly why A becomes B. Roughly at the end of the 19th century, it was discovered that stuff is made up of molecules, discrete little things, and And that's when the second law of thermodynamics was formulated, primarily by Boltzmann. And basically, as a result of that dramatic insight, we understand why processes, chemical processes occur, why physical and chemical, why stuff happens, why does wood burn, why does all chemical processes basically understood. Then one has to ask the question, now, life is ultimately just a chemical process or lots of chemical processes. Why are we struggling to explain the life phenomenon? And the answer is because life does things that are totally unexpected from a physical chemical point of view. And I guess three particular characteristics that stand out are suddenly chemical stuff becomes purposeful. It seems to have an agenda. Normal chemicals, don't have an agenda. And then there is this extraordinary level of complexity that comes about. A bacterial cell, the simplest living thing, is 9 orders of magnitude more complex than just a regular chemical aggregate. 9 orders of magnitude, just to make that clear, is the difference in size between a coin and the planet. So there was an extraordinary process of complexification that took place, and it puzzles me that biologists are arguing, was there a tendency towards complexity in biology? My God, of course there was. I mean, there it is, 9 orders of magnitude, and that was just the beginning. Once you had the bacterial cell, then the eukaryotic cell and multi-cell, etc. And then there's the mother of all problems. We have a mental dimension. My God. Now, we all believe, I think we all believe that that mental dimension has a physical chemical basis. A lot of the work in neuroscience has been trying to find correlations there, neural correlates as they call it. But if you ask a physicist, can you explain that? He can't. And when I say, can you ask a physicist, people have been asking the very clever physicists like Erwin Schrödinger. He's considered to be a very clever physicist. And when he spoke about consciousness, he says, well, I don't want to use rude words, but, we have no idea what's going on here. We do not understand that. It's just totally out of reach of physics, which is basically, if we think about that, what it's telling us is that the physical and chemical sciences are incomplete, because if there are bits of physics and chemistry, like purpose, mind, that aren't explained by physics and chemistry, and that's the situation, then there's something missing in the fundamental, in the physical sciences. And that explains why biologists have been struggling for 100 years to understand evolution, because they can't understand evolution because there's a process here that doesn't seem to fit into the normal physical chemical way that things happen. Okay, so something dramatic happened that I think most people aren't aware of. It was roughly some years after I started off in the early 2000s, I postulated that there are not just thermodynamic states of matter, but there are kinetic states of matter. And it was very speculative for me to say that at that time, because there wasn't any physical evidence for that. But in 2010, 2 Dutch chemists actually made, for the first time, a hydrogel, which was a kinetic state of matter. Now, let me just say, what is a kinetic state of matter? And it's very important because basically I'm saying all life is just an unusually complex kind of kinetic state of matter, okay? So I'm now trying to characterize life in physical chemical terms, but in a way that hasn't been clarified earlier because we didn't have experience with that kind of state of matter, a kinetic state as opposed to a thermodynamic state. Now, just to make clear what I mean by a kinetic state, It's a little bit tricky to understand, but a physical analog that helps understand the process is a water fountain. Now, a water fountain is, if you look at the water fountain, there's this wonderful fountain in Geneva, goes up, I can't remember, 150 meters or something. You look at it and it's persistent. It's there all the time. Whenever you go to Geneva, it's doing what water fountains do. It's there. But so it's persistent, even though it's not stable. Of course, it's not stable, because if you don't have that pump pushing the water up, you don't have a fountain. The other strange thing about this water fountain is you're looking at the fountain, you say it's the same fountain. Each time you go to Geneva, there it is. But the water that makes up the fountain is continually turning over. Now, that's a physical kinetic state of matter. Not terribly exciting. We all understand that. But life is a chemical kinetic state of matter. We're like a chemical fountain where stuff is turning over all the time. So all of you, I'm looking at you now, in 3 months or 4 months or whatever, in a material sense, you'll be a totally different person. It's still you, like the water fountain, but your stuff is turning over all the time. Now, if we didn't have an understanding of what life is, how can we have, if you don't have a theory of what life is, how could you have a theory of how life changes? You can't have a theory of change if you don't know what it is that is changing. So we had a good theory of change in the inanimate world, because we understand molecules and basically second law of thermodynamics, you're going to more probable states. That's basically the second law of thermodynamics, going from less probable to more probable. But that's not happening in the biological world. And basically, once you understand that there are kinetic states of matter, the driving force in the kinetic world is not from thermodynamically less stable to thermodynamically more stable, of course, because energy is continually coming in. The new rule that I think that describes the behavior of systems in that world is the persistent principle. And the persistent principle was first formulated by a very clever computer guy called Steve Grand, who wrote this wonderful book called Creation, Harvard University Press in the year 2000. And he said something in that book that kind of is staggering.
Eddie,
He said,
can I ask you a question?
yes.
Do you think you'd be willing to do a scholars talk on DKS for us either in July, second Friday, or August, second Friday? So that would be July 11th this time, or it would be August 15th or August 8th this time. Would either of those possibly work for you?
Oh, listen, we'll possibly, yes. August is not going to be good. I'm going to be in Australia.
What
and
about
the time difference there is terrible.
Maybe September. How about September 12th? Would that possibly work?
Well, listen, again, I'll be in Australia for that period for several months from.
Maybe when you get back. Maybe you get back. You can give us the time. I'll send you an email.
Okay, let's figure it out by email.
Yeah, because I know. I think everyone wants to jump into this DKS a lot deeper.
Yeah.
And,
I realize I'm going into this in too much detail at this stage, but let me just try and say the central point that I have to tell you what this guy, Steve Grand, said. He said the most important law of nature is the following, and it's one that no one's ever heard of. And he says it's the most important law of nature. And I think he's right. And the most important law of nature is this: things that persist, persist, and things that don't. Now, I prefer to rephrase that a little bit and say things tend to go from less persistent to more persistent. And actually, that encompasses the second law of thermodynamics. But whereas the second law of thermodynamics only does thermodynamic stuff, this one does kinetic stuff as well, and it applies to us, to kinetic states of matter. And basically, evolution is the drive towards more persistent forms. That's it in a nutshell. And the only other thing I'll say now, because I think, you know, this blew me away. I've been reading up trying to become, sorry?
This is our time. This is our little time signal whenever we.
Okay. I'll
So
stop.
but in the future, I'd love to hear you keep going on this. This is great.
Okay.
A scholar's talk would be fantastic. But
Brilliant. Brilliant.
David has had his hand up for a while.
Yes, colleagues, I'm sorry I missed the discussion. You know why? Because my position came in, and I'm now scheduled for a stent tomorrow morning, a major repair. Oh, so I just wanted to share that. I missed it. I just want to very briefly say how I was introduced to Conway Morris and to Stephen Jay Gould. It was a debate in the Natural History magazine back in the late 90s. And Gould took the position the origin of life was very likely, but if you play the tape again, it'll be very different, right, in evolution. Conway Morris took the opposite point of view. Okay, my point of view from almost the very beginning that I believe both were likely and driven. Right. Okay, and that's where my research has followed up, particularly finding the isotopic and geochemical evidence for the hot early Earth climate in the Archean. That's where it's at, and it's still very controversial. There's a continuing debate on that. I won't get into that now. Now, as far as what a very interesting point about the kinetic state of matter, life being in a kinetic state of matter and persistence, I would argue that temperature is a constraint on that possibility of being persistent, of systems becoming persistent and evolving. And so that's in a nutshell what I wanted to share. I hope it's not redundant to previous discussion. But and I want to say one final thing. We haven't gotten up to the culminating chapter of the book, Animal Mind. I read it, all of it except that. I am going to say that I am going to be likely in very strong disagreement with Conway Morris's position because I suspect that he is influenced by Teilhard de Chardin, a mech principle.
Yeah.
Yes.
I know, by the way, I greatly respect Conway Morris. I've known him for many years. We met in the UK. I actually gave a talk at Cambridge that he attended, and he met my dad, who was not a scientist, and with no trace of pomposity. He talked to my dad like he would talk to anyone else. And I admire that in all scientists, you know, that they can converse and treat people with respect without the background that they have. And in any case, that's my little anecdote about Conway Morris. And you know where he comes from regarding his religious beliefs. I do suspect that there is some overlap on this issue, but I may be proven wrong. I'm not about the rest of the chapters, but the final. Thank you. Thank you for having a chance to say something.
Oh, thank you, David. That was great.
Thanks, David.
Pushkar, you had your hand raised.
Oh, yes, I mean, just to add, to take it ahead from what Adi was saying, that, we don't seem to exactly know, what is life. So we can describe, let's say, what life does, but what exactly is life, we are not, we are not exactly sure of that. But to add on to that, I think I haven't got a chance to read the book, but I got GPT to, let's say, summarize some reviews for me, and I hope it did a good job, because what I'm going to say next is based on that. I think in the book somebody mentioned that evolution has some sort of a purpose or a direction. And is that correct, Daniel? I don't know if you read the book.
I don't think I don't know what he personally thinks. I don't think he's explicitly made that argument in the book. He might believe that, but I think so far it's just that the evolutionary process is more constrained, with certain outcomes being more likely than evolutionary biologists generally appreciate. I think that so far that's been my reading.
Yeah, so just to add into this whole convergence thing there, I mean, the very normal example, it's sort of given you have a building and, there are only certain ways you can go to the top of the building. You can take an elevator, or you can, climb up the pipes or take stairs. But there are finite ways how you can still go up to the top of the building. But it does remain as a fact that for these ways to become, let's say, valid, there has to be a purpose in the first place, which is that we have to go to the top of the building. And therefore, if we take out the idea of purpose from evolution, not having a purpose or not having a direction, then the very idea of convergence itself, I think, it becomes little dodgy. And so, yeah, I think that's all I wanted to, make the point, and let's see how the conversation develops.
No, it's interesting. Yeah, I don't know if he'll say it later. I don't know if, has he ever explicitly said anywhere in any of his writings or talks that, like Teilhard, for example, had a clear picture of where evolution is going. I don't know if I've ever heard Simon Conway Morris say anything analogous to that.
Yeah,
but
I don't recall anything like that. I think he's super careful, like you say. But right. I do think I'd be very curious on this question of Addy's, the purpose is persistence. I wonder what he would say. Is that one of the fundamental purposes? I'm very curious what he would say. Maybe we could ask him that.
I got the feeling that Addy had about 60 seconds or 2 minutes left to finish. I think you were getting to a point and you hadn't quite got to it, Addy. And could we trust Addy to just do 2 minutes and not do 20 minutes?
Yeah, of course.
I think you were close to it.
First of all, I should apologize that, I've come to a talk on a book that I didn't read, and therefore my intention was to listen and not to speak. So that's my justification for having done that. But of course, I'm familiar with his thoughts, and so I'm connecting with everything that's being said here. But basically, and this is stuff that I've just finished writing up in a new book, that there are two ways to get to persistent forms. There's the well-established thermodynamic way, and guess what? There's another way, which is the kinetic way. And life has just discovered another way towards persistence. And the persistence in life is based on certain molecules, nucleic acids and proteins, etc. But in principle, you might be able to create a different kind of dynamic chemistry, kinetic chemistry, that leads to, provided energy is coming in, because if energy doesn't come in, you can't maintain a kinetic state. That's how the fountain in Geneva stays there. There's a pump there continually being energized. So that's basically it. And therefore, once you put life in a physical chemical context, you can talk about what it is, and is there evolution and why? And of course, evolution, just like in the inorganic, the non-living world, there's a direction to processes. There's a direction in the living world as well, from less persistent to more persistent, and which tends to be from less complex to more complex, and et cetera, et cetera. So hopefully that kind of just closed that little bit, so where I was going becomes a bit clearer. And I'll be happy to talk about it in more detail at another time.
Yeah, I'd love to hear more like how information and Salty's infodynamics fits into the thermodynamic and the kinetic way. And, you know, where does information and mind come into both of those? I'd love to hear you talk about any of that in the next.
Okay. I won't say anything now then. Yeah. Otherwise, I won't stop. Dangerous. Yeah.
I think we're all constantly on the brink of talking for like 2 hours about our angle.
Yeah.
I think we're all aware that like of that tension. Yeah. But you navigated it well. I'm gonna try and talk for 2 hours about my obsession. Stop me in 5 minutes. But Daniel, I love when you were saying at the beginning that you found that astrobiologists were weirdly open to every possible area of the possibility space being explorable by life, which is fucking crazy. Like it's
crazy.
I think that comes from this fundamental assumption that underlies astronomy, cosmology, astrophysics that isn't even explicit in the theory, so it doesn't get examined, which is that this is an arbitrary one-shot universe where matter has arbitrary random characteristics, and we're going along an arbitrary random path. And if something amazing happened on that arbitrary random path, well, it could happen just as amazingly on all these other arbitrary random paths. And that comes from the fundamental failure to understand what this universe is. And I think cosmological natural selection says this isn't an arbitrary random universe and matter doesn't have arbitrary random qualities. They have been fine-tuned by evolutionary processes. And in that case, if that's true, matter itself has evolved, evolution itself has evolved, life itself has evolved outside the lifetime of this universe. So a lot of the constraints on the pathways that could be explored were already explored in earlier universes, and they were dead ends or whatever because they didn't, and I think the failure to take that approach to it messes up guys like Conway Morris and messes up a lot of people, because what they're essentially trying to say is this chemical structure that life comes out of looks molded so as to enable life to come out of it, which kind of tightens the pathways but makes them more walkable. But they can't say that because that's evidence for God, because the only mechanism that anyone assumes could possibly shape a universe so that it is deliberately prone to producing life is God. And they don't realize there's another mechanism, which is evolution, will give you exactly that kind of outcome. So you end up with this weird situation where all of the atheist, fundamentalist, materialists are denying the evidence that this universe was crafted to produce life because they're afraid it's evidence of God. And what they're actually denying is evidence of evolution at the level of universes. We've got this weird flip from the era of Darwin. Anyway, that's my take on this.
No, I think that's really fascinating. I just read last year this book, Universes by John Leslie. I don't know if anyone's familiar with John Leslie's work. But it's all about the anthropic principle and fine tuning. And that's he takes that approach, as you said, is pretty common, that this universe is just this one-off event. And what are the chances that it just happens to have all of these constants and the ratios between forces that permit not only life, but, ourselves. And and he pretty much either frames it as that or God. And he does that very explicit. Those are the only two options. This is just some random one-off universe or God. That's it.
Dichotomy. It's a crazy false dichotomy. What you end up with is, materialist reductionists arguing for creationism. They're arguing that the universe was created out of nothing in a moment of creation, and it perfects itself over time. But there's no reason for that. There's no history, and it's weird. You end up with a creationist, reductionist materialism. It's absolutely bizarre.
It's a funny way of putting it. Yeah.
Are you going to open your book with the myth of unconstrained randomness?
Me on my book?
Yeah, your book, because this sounds like it's fundamental concept to get across to a lot of people.
Yeah, I don't know how early I'm going to put that in. I mean, I have a thing on my Substack, which might end up being a chapter in the book, which is in cosmology, all of our errors lean in the same direction. Because you find in cosmology, they're consistently startled by emergent, complex, orderly structures at every scale, and they're constantly surprised to find them. Like the further back they look, there's orderly, complex structures. The smaller the scale is orderly, complex structures. The larger the scale is orderly, complex structures. And they constantly expect randomness, and they never find it. That's why the James Webb was so interesting, because they had 1 billion years left that we hadn't observed anything in which they assumed they would just find randomness. The randomness had been herded into the first 1 billion years. That was the only place left where they could find completely random, arbitrary behavior. And now they're not finding it. The James Webb is finding orderly structured, complex structures right the way back. So eventually they're going to have to realize the whole paradigm is wrong. And I think evolution is the answer, but maybe I'm wrong. But yeah. But yeah, you're right. I keep trying to draw attention to this unexamined assumption that underlies all the actual theory. Yeah.
That's interesting. It makes me think, in the book, he said something like life was born complex. He's citing someone like this original complexity and then the streamlining, but is this like that the universe was complex from the very beginning, or more complex than astronomers?
Yeah, well, if
I'm not a cosmologist.
I think it's the same analogy that he uses in chapter 1.
That's what I was trying to understand.
Yeah, the myth of initial simplicity
versus
the possibility that it starts as a network and then it prunes. It starts as an interconnected complex network and it prunes. The way all the introns, we have less introns today than we had before, according to Kunin, right? It's like there's this pruning, and obviously biological development happens exactly like that, right? Which to me feels that's like a hidden insight. It's a huge one.
It's really cool. I just want to say Pushkar raised his hand, and then David shortly after.
Yeah, sure.
Just want to give Pushkar.
What Julian was saying. In fact, I wrote a paper, something to do with cosmological natural selection, but I forgot what it was about. But just to add to the fact that you mentioned a couple of things, like let's say the God sort of a hypothesis, the God hypothesis, and then you said that evolution can explain the same thing. But as I mentioned, earlier in my introduction, so being from India, we naturally bring in spiritual things just by default. So astrobiology, let's say with spirituality added to it. So one way of looking at it, in a very, very Vedantic way would be that the God and the evolution are actually together. It is God which actually evolves into you and the universe.
I agree with you.
Yeah, and so that sort of, let's say, like a common ground. So it can be explained entirely without the need of any creator God, and simultaneously, it can still go along. And that's what we look at it here, at least. So,
yeah, I mean, that which ties in with what Teilhard de Chardin said, the universe is God coming into being. And my argument would be relatively similar in that, if universes are fine-tuned to evolve complex life forms like us and our technologies, and there's going to be a trillion more, trillions of more years of this inside our own universe. Imagine how complex consciousness is going to get inside that universe. It's essentially going to have all the characteristics that we currently ascribe to God. Universes become godlike over time. So, and we came from a parent universe, or the parent universe was a godlike universe at some point, or has become a godlike universe. So it's very Vedantic. It's very like I read the Bhagavad Gita and I was going, wow, this is like documentary. You get. I think this fixes a lot of the problems between religion and science in that you sufficiently advanced and developed universes. You could call them God if you want. They're very, very, very similar. They've got remarkably similar attributes. Yeah.
I want to understand, are we moving in the direction of joining up between religion and science? Because if that's the case, I will feel uncomfortable. I think science does very well.
Sure.
We should just jump in and say, when we set up this group, we said, naturalistic explanations of greater than human intelligence are going to be allowed, but as far as other
Right.
ab initio creation and omniscience, omnipotence. We don't want any of that discussed in the group because there's plenty of other forms for that.
Yeah. No, I'm trying to do my whole approach is to say you can completely explain in material terms, just using evolution and universes, and the standard model of particle physics, and with nothing added, you can explain you can explain incredibly richly complex conscious universe. You can see how they come into being without explaining, without any woo, without any creator god, without any of that stuff at all. You don't need any of that stuff. That stuff kind of melts away. In a way, that stuff becomes a story we told ourselves trying to explain how complex this universe gets and why it gets this complex. It's the story you tell when you don't have evolution as an explanation. It's exactly how it was the story we told about animals before Darwin came along. I think the same thing's going to happen to universes. That you don't need the religious outside of material reality kind of explanation when you realize how complex and rich the material reality explanation is, how deep it is. That's what I would say.
Let me say a few quick words. I follow Facebook. I admit it because I do find some very interesting articles on different sites, but I also come across to the biblical propagandists, the creationists, and I can't resist polemicizing in a respectful way back. I call myself a spiritual materialist. Okay, so I see emotion, spirituality, and so on as emergent property of an attractive state of social animals that encephalize and become encephalized. That I think that's a common feature that emerges of the social animal certainly in the Cenozoic. I just want to make one comment about James Shapiro and his book, which I think is very important. And the creationists like to quote out of context his support for intelligent design. He's not really supporting intelligent design. He is working out empirical research mechanisms that allow life to break with the neo-Darwinian paradigm and actually become more successful, kinetically more successful, perhaps more persistent. And I look for in preparation of today any discussion on convergence in his book, and I didn't find any. But I suspect that the mechanisms that he goes through exhaustively have some real bearing on the phenomena of convergence and evolution. So that was the remarks I wanted to make regarding what we were discussing. And I think that we had a debate once with Charlie Lineweaver and with Conway Morris. And you know what Charlie's position is, we're, at least more recently, that we're unique, non-repeatable. I'm amazed that Conway Morris seems to have been converging back to a position that he disagreed with before. Anyway, nevertheless, We have a visitor, and thank you so much for having the opportunity. Another doctor has showed up. I'm gonna mute and try to follow the rest. You're almost done anyway. Thank you so much.
Be
Yeah,
well
thank you, dude.
Good luck
and get
tomorrow.
through your operation smoothly.
Yeah, good luck. We'll see you on the other side.
Yeah, getting closer to the end, I just wanted to, I think we covered most of the things that he talked about in the first two chapters. The third chapter, though, the myth of mass extinctions, I found really interesting. So for the people who haven't read that chapter yet, he seemed to be arguing that like the major groups that go extinct during mass extinction events, and then the groups that radiate afterwards, these aren't random. It's not just contingent. There's this, David Raup was this paleontologist who wrote a book called Extinction, Bad Genes or Bad Luck, right? And kind of the view emphasizing contingency was just, it's random why some lineages persist and why others go extinct. So with using like the end Cretaceous mass extinction as like a extinction event, I think that most people are familiar with. The common argument, of course, is that if this bolide had not impacted the Earth and dinosaurs did not go extinct, mammals would not have had the opportunity to radiate afterwards. But in this chapter, he argues that there are signs that not only mammals, but also and not only mammals in general, but mammals including like primates, as well as angiosperms or flowering plants, and birds were already we're modernizing, and we're radiating prior to the extinction event. And he thinks that even if the asteroid had never hit, this kind of succession, the waning of the dinosaurs and the ascent of the mammals and the angiosperms would have happened anyway. So he very explicitly argues that mass extinction events are just accelerating the inevitable, as opposed to determining purely which groups succeed and which ones fail. And to be honest, I had never heard this perspective before. If he's written about this earlier, I'd never come across it, but I actually found this to be really interesting, because at first I thought, how can he make this case? But he does a good case. He uses two examples, the end Cretaceous mass extinction caused by the asteroid, and then the largest of the big five mass extinctions, the end Permian. And he shows evidence, trilobites were one of the main casualties of that extinction, but shows that they were already on their way out. But anyway, I thought that was actually my favorite chapter out of all of these, but I'll stop. John.
Yeah, well, it was actually my favorite chapter too. Although I was super interested in that myth of initial simplicity at the beginning of the first chapter, which I really think was two. It was the myth of initial simplicity and the myth of no limits, right? I think he actually had two fundamental concepts in that chapter, and that's what I emailed him about. And then he said, "Sure, I'll come in and talk." So it was clear to him that we understood. We're getting what he's saying. But I'll tell you this. I'll tell you what my thinking is around this. My feeling around this acceleration. Right. I used to call that catalytic catastrophes, right? Catalytic catastrophes.
That's so cool. Yeah.
There's also the phrase eucatastrophe, which doesn't work as well. Some people use it, a good catastrophe, right? A eucatastrophe. But people don't use that because because the two actually fight against each other. The roots of the two, good and catastrophe, good, bad, right? So that word is very rarely used, but catalytic catastrophe, you can do a search for that and you'll find people who use the word.
I've never heard of this. It's great.
Yeah, but so I actually invented a term. I call it.
That's great.
Yep, I call it hormesis. And,
I have heard you talk about that. Yeah.
Yep. So I stole it from the biologists who say a small poison, actually causes this hormetic effect where the cells protect themselves. And my intuition is that this is a network effect, because if you say what is the property of networks that make them stronger when you stress them appropriately, you get to muscles, you get to immune systems, you get to nervous systems, you get to bones, you get to circulatory systems, respiratory systems. Every single one of those systems, if you stress it within its design parameters, reorganizes resources within the network, reorganizes resources to allow a more adaptive general response from the network as a whole. And so once I started looking at the great extinction from that perspective, I suddenly thought, well, what would the network be? Well, all the developmental genes are conserved in every single one of the great extinctions. And then you have to argue, what about the non-conserved genes, the ones that aren't protected from replication to replication, but they're reassorting, right? And I found some people who say that most of those are conserved too. I haven't found any single paper on it, but I found people making this argument because there's so much allelic redundancy. And so if most of the genes are being conserved, then the super adapter is neither the species nor the individual, it's the network. The super adapter is the network that is actually getting stronger. And so for me, it's a hormetic effect or hormescience or hormescient, right? That it's close to the term antifragility, which is used by, our friend Taleb. Yeah, Nick Taleb. But it's not, but antifragility is things that gain from disorder. But hormesis is things that actually get stronger from stress. So I think it's a more fundamental, but if you argue it's a network-centric thing, then to wrap up that long thing I just said, I'm sorry, he identifies all of these species that were already waiting to move into the niche, right?
Right.
And so the network was ready, I would argue,
Right.
in any of those particular catastrophes to reorganize. It wasn't,
Right.
it was not that's why I would argue it's not an evolutionary event, or excuse me, a creative event. It's a developmental event. It's a development of the network because the process, there's a constraining that happens because of this catastrophe, right? So now it constrains the network, but I think it constrains it towards more general adaptiveness. This is that phrase, that maddening phrase that I love, that there's a general adaptiveness of the survival of the network. And so I'm going to shut up there, and hopefully that.
Aren't you just putting across the argument that complexity is there's a driving force towards complexity? Am I right in understanding that that's the implication of what you've just said? Is that right?
Well, I would say that there's at least two that I can see. There's there's a niche specific complexity, which could become greater or less depending on the niche, right? Like blind cavefish, right?
Yeah.
But then there's this subset of the complexification that involves an increasing general adaptiveness of the network. And this is where intelligence comes in, I think, or a network adaptiveness, if we could say, right? There's a network adaptiveness to these new forms.
Yeah. Isn't the network complexity, the network itself, an expression of complexity?
Yeah, I see three actors. I see the individual as a primary creator, and the group as a primary protector of certain things that define the group. And then the network seems to be this connected set of individuals and groups that are competing and cooperating both, right? Co-opetition. So I would argue that there's a kind of a cooperative network, right? That is benefiting from these catastrophes that he's describing. So I would try and look at that set of species that have gone into the way all the niches were reoccupied quickly in the adaptive radiation, right? I mean, 1.5 million years after, I think he said in his chapter 3, right? Some of these, I forget what the forms, it was a pelagic fish or something. They didn't get hurt. I forget what it was. There was a certain clade, and they just within 1.5 million years they occupied those forms again. And so I would argue it's that in that case it was the network going into the form from because it maintained the complexity spread across the network, but not in any individual species.
No, this brings to mind, I was trying to find, I've had some colleagues, paleontologists, who were arguing that, so mass extinctions as a whole really only applies like the past 500 million years of Earth's history, where animals and plants reign. But apparently the modern biosphere is less susceptible to extinction than the earliest interval of this window. So the Paleozoic, like the beginning of the Phanerozoic, was more prone to extinction. So the idea is that, you know, 500 million years of this kinds of stress and going through these crashes and rebounding, the modern biosphere now is more stable or more less susceptible to kinds of extinction events that was more susceptible to earlier on.
And does the Great Oxygenation event count as an early one or not?
No, because that was like 2.5 billion years ago, and so the Phanerozoic is the past 500 million years or so, starting with like the Cambrian period, and this is when animals first really start diversifying, and later on you get plants, and it's essentially the modern biosphere. And usually when paleontologists talk about mass extinctions, they're talking about, you know, events that happened in the Phanerozoic that primarily affected animals and plants. But it looks like over the course of the Phanerozoic, the biosphere has become more resistant to extinction. I just put in the PNAS paper there, which is really, so that's what you were saying, John. That's what it brought to mind.
There's a resilience. There's
exactly.
There's kind of a strengthening that happens when you know, my other last example I would give is HIIT, right? High intensity interval training. It's totally known that if you stress your networks multiple short cycles, your VO2 max, your peak power, your speed, your immune function, and your recovery time, all 5 of those variables in the same exact amount of time, right? Doing these short sprint recoveries versus say 70% max exercise, right? You get those improvements to the whole network. So there's another interesting example there of the little stresses kind of that there's something better about that than, you know, this very primitive model that punctuated equilibrium. Oh yeah, okay, we keep this nice, stable. No, there seems to be this constant stress where you do get that resilience. Maybe we should get that person to talk in this PNAS article to tell us about how they measured this, because that sounds wonderful.
Yeah, sure. Yeah, they link it to like increasing oxygen availability and the physiology of animals. But yeah, sure. Yeah, we were lab mates together, so yeah, I could ask them. Yeah.
Thank you. That'd be wonderful.
No, and then, Carlos, all of your comments have been great. Yeah.
Carlos, amazing.
I took screenshots of all of them so I could follow up on all these references and everything. But
I told them I'll put them all in the notes. So.
Oh, perfect. Yeah. No, because there's this idea, you know, looking at mass extinction events, and then of course before mass extinction events, things like the initial oxidation of Earth's atmosphere, or these few instances of a snowball Earth where we had ice at the equator, you know, for hundreds of millions of years. On one hand, I've seen people use these events to argue for the fragility of life, even in this kind of anthropic sense, where it could have been that the biosphere could have completely crashed or gone extinct at any of these major transitions. And of course, given our existence, you know, we exist on the planet where, you know, the planet was able to rebound after them. But it could be that these were necessary events in the development of Earth's biosphere that helped create the biosphere that we now occupy today. So if we hadn't gone through these traumatic, incredibly stressful events, you know, like for example, before you get into the Phanerozoic, which literally means the age of visible life. So when animals diversified, you had at least 2 snowball Earth events and changes in the chemistry of the oceans and atmosphere. And it was a very turbulent interval of Earth's history, way more turbulent than any kind of recent climate perturbation. But at the same time, that was the interval that on the other side of it gave birth to the modern world that we all know, that's replete with oxygen and, you know, diversity of multicellular animals and plants. And people are still debating the connection between these two. How did these crises precipitate the birth of the modern world? And it could be that maybe they had an important role in establishing the sorts of conditions that make the modern biosphere possible.
I think I read a paper on the, I can't remember what it was, about how the ice ball, you know, snowball Earth drove what was necessary to get to multicellular life. And I can't remember adaptation like that actually was a forcing function for multicellular life. Yeah.
No, that's right. Yeah, one of my colleagues, Carl Simpson at the University of Colorado Boulder, has been arguing this, that essentially the initial transition from like a single-celled life form to a multicellular eukaryote happened in response to the changes in viscosity, which Simon Conway Morris talks about, this life at low Reynolds numbers. You know, for microbes, life in water is like life, it'd be like if we were swimming in molasses. But that increased viscosity associated with declining seawater temperatures associated with the glaciations would have provided a selective pressure for these unicellular eukaryotes to become multicellular. Yeah, so there are people like this who argue snowball Earth was crucial to the evolution of multicellular life.
Which is very interesting, because one of the things I've been writing about for the book and I've been researching, so it's very interesting to me, is the icy moons with liquid water oceans. And like most of the liquid water in our solar system is under the surface of icy moons. And it would be really interesting if life was force functioned by icy moon conditions, because that seems to be actually what our universe biases towards, rather than surface oceans on rocky planets, because we've only got one rocky planet in our solar system that was able to hang on to its surface water. All the icy moons can hold on to their liquid water oceans because they're kept liquid by a different mechanism, a more frugal mechanism. So I would
ask this question. Do you think you could seed from, say, an icy moon? You could seed a bacterial spore with like a comet skipping off of it to a water planet. Is that possible?
I don't see why not. Like, you know, we've got liquid water from Enceladus blasting up out of cryovolcanoes in pretty huge quantities, and there's no reason why some of that couldn't drift to a rocky planet. And if there's life refrozen in that, some of it could survive the transit. You know, it's been preserved. So you could see that inside the solar system. You could see that happening. Yeah.
Just a comment regarding the growing complexity of the biosphere, the Lovelock, the Gaia idea, which initially in the 70s, 80s, whenever it came out, I don't remember exactly, was considered by conventional biologists as a little bit far out. I think the tide has turned, and it's now increasingly supported. Or Doolittle, I think, has just he's written a paper on that, and basically saying he's more or less on board, and written a book that I think just came out very recently. In other words, and John, it fits in with what you just said. When the biosphere becomes more complex, it becomes more resilient. And if it's more resilient, it is more persistent. And that's the direction that it naturally moves towards, to be more resilient, more persistent.
Yeah, I think that's great. So Carlos is published with Ford. And I think it's funny because Ford was one of the biggest critics of Gaia from, the biology standpoint. And now it's the song, not the singer stuff is really taken off. And now you have a lot of like Lovelock's protege, Tim Lenton, is now taking this very seriously and modeling these sorts of dynamics that Ford has been talking about. But I think, yeah, that's a really interesting historical development. I know, Carlos, if you have any thoughts on that, having worked with Ford.
No, but it's extremely loud here.
Sorry.
Anyway, yeah, sorry. Ford is great. I want to read that book. I should read that book. I've read parts of it. Anybody wants to read that with me, just thrilled. Yeah, Ford had a sort of come to Jesus moment with Gaia. That he didn't take it seriously enough because he was Darwinian in the 70s. And then the more he thought about it, the more he wrestled with ideas of clade persistence and selection, evolution of persistence, those kinds of things. And Gaia begins to sound more and more reasonable. Start thinking about evolution not in the constrained way of like the Lewinson formulation or whatnot, but more as like guessing and checking over millions of years, and that could apply in all sorts of different aspects of the shared life, and all sorts of ways.
Yeah, I think that's so cool. I wonder if Simon Conway Morris has any thoughts on Gaia. I don't think he mentioned. He hasn't mentioned it in the book so far, as I tell.
Right. That'll be a chance to open his horizons a little.
Yeah.
Especially Lovelock's last book about kind of the intelligence, the IT systems becoming Gaian.
Oh yeah.
Awesome.
I never read that one. The Novacine, is that
Yes.
that one?
Awesome.
Yeah, I haven't
good.
read that one.
Good,
Yeah.
it's fun.
Okay. Yeah,
Yeah, it'd be
like Mark's
really
first
cool.
talk.
Well, we should think about whether either you, Daniel, you, Carlos. I mean, you guys are both very directly extensions, I would say, of what Conway Morris has just been discussing. I don't know if you guys would like to come on, as the next ones or something after this, as scholars talks, and maybe we could get Conway Morris to attend those. I think it'd be pretty awesome.
I think that would be amazing. Yeah, thank you.
Good.
And
Great, wonderful.
And so we've essentially read, I realized this today because, John, as you noticed in one of your messages, most of it, there's almost 200 pages of notes in this book.
Amazing.
So we're actually halfway through it. There's if you actually look at the non-note section. So I would be happy to read the rest of the book and have a follow-up discussion. But I remember this is something we kind of left open.
Yeah. Yeah, I'd be super up for that, especially if we can get him to attend, or even if not, we can just invite him at least.
Right.
So I think it'd be great, and then maybe we could decide then, next book. I know that Steve wanted to do. Steve, you had something you wanted to say about a list, right? We can build a list of possible books.
Yeah, my idea was to send out a Google Doc and have members Evo-Devo. See if I can just show you what I'm talking about. I can't get it up. Anyway, just send out a Google Doc where invite everybody to suggest a book they would like us to read, and at least one. If I asked people for more than that, we'd have hundreds, I think. But if everybody their favorite book on there, and you'll see it, the little form, author's title, your name, and the person's name and email, and then a little column where if you second the motion on a book that somebody else has listed, you can put a little mark in there, and we'll from that list we'll pick. We can go and pick the next book as it comes up. I had a book club at university, and we used to pick a book, and we would just stay with that book until everybody was kind of done with it. We didn't really have dates or new books. As it was getting toward the end of the discussion, after weeks, we'd sit around and talk about another book. But this would be a source of books that members can go to, and when one is winding down, like Morris's next time, we'll be able to go to the list and get the next one, and they'll all stay there. And if a book comes up later, you can always add it, and we'll get a consensus ahead of each sort of reading period before we meet again. That was the idea, and I'd kind of organize that and send it out.
Good. Yeah, as long as we all get to, as long as it's the participants that are voting
Right.
at the event, I think everyone will be aligned there. That sounds like a wonderful thing. We can all throw our stuff up. And I had one question on cadence then. If we're going to stay with the 6 books a year, every 2 months, if that's what we want to stay with at the moment, should we do scholars talks kind of in between those? Like what is a cadence people would like, everyone here would like to see, or does it not really matter to even think about that? We'll just kind of take a shot. Some months we might have a scholars talk and a book club. What would you guys prefer? 12 talks, 6 talks a year on average?
Yeah, for me, I wouldn't mind if there's a scholars talk in close proximity to a book discussion, because they're different enough for me. Yeah.
Yeah. Okay. And then what do you guys think about, do we need to have, should we be, I know a lot of people just go away for summer. So do you think that like August, we should take certain dates, certain months out, or is everyone okay with like having one in August and having one in July and June? Or should we just maybe consider those 3 months, less likely for scholars talks? Does anyone have any thoughts on that? Yeah, I'm okay with any of them myself. So if you guys are okay, why don't we just to see if we can fill up our dance card?
Yeah. Good.
Okay. So then that leaves us for, if we do it that way, then we have our next book meeting could be August 6th or September 3rd. That's first Wednesdays, right? Unfortunately, I have something on August 6th. That week, I have a thing I have to go to. Would September 3rd be okay for our next one? For our next book club?
That would work for me. And then that would be the rest of Simon Conway Morris's book. Yeah. That's
for number
plenty
2.
of time to,
Cool. All right, well, wonderful. Well,
as far as John, just as far as scholar meetings and book meetings, different people will be attending different ones. So if they in the same month, it's not like I've got 2 things.
Good point. You're right. It's different. People come based on their interest. Good point. Thank you. Okay.
So 2 in a month, or 6 or 12 of each, you probably get all the attendance you want.
Wonderful. Any final words for us, Daniel?
No, I thought this was great. I've benefited from book clubs like this in the past, and it's been a while since I participated in one. So I'm just really grateful that that the idea came up and we made it work, and this was a lot of fun.
Yeah, thank you for
thank
suggesting
you all.
it. Thank you for suggesting it. Thank you for picking the book and for leading it. It was really exciting for me to read this this first half, and I think I'm going to agree with David. I think I'm going to have some thoughts for him on the last chapter.
Yeah, because he keeps alluding to it, and I don't know what his argument is yet. So I am intrigued. Yeah.
All right.
Well, thank you, everyone. And were there any follow-up things, John? Like, I'll talk to my friend about. You were thinking he'd be interested in doing a scholars talk, like. Okay. I'll reach out to him.
Yeah, it's the same time as we typically do them. I believe it's second Fridays of any month.
Okay.
Yeah, same time. I think it's noon to 1:30, something same as this, I believe. Yeah. So.
Perfect.
Yeah.
Okay, great. All right. Well, thank you, everyone. This was a lot of fun.
Thank
Hope
you,
to
guys.
see you at the next one.
Really appreciate it. Take care.
I hope.
Take care. Bye-bye.
That was great. Thank you very much.
Yeah.
That was great, John. Well done.
Wonderful, brother. I'm gonna turn this off. Turn off the recording. Here we go. Maybe